Hello everyone, welcome back to my channel. Today I am going to start with a new chapter, that is differentiation. Continuity and differentiation are the two chapters combined in your syllabus. Now I am going to deal with some problems of initial exercise from the chapter differentiation. Okay, let us see the prerequisites. Prerequisites are, you should know all the differentiation values for all 6 trigonometric functions. That's for sine, cos, tan, cosec, sec and the other one cot. Now, along with that, you should know how chain rule and how product rule works in differentiation. If you know that, even if you don't know, please keep all that formulas aside while solving the problem. Eventually or gradually while solving, you will come to know about them, or you will be familiar with all those formulas. Now, let us start with the first problem. 2x plus 3y is equal to sin x is the first problem given. We should differentiate the given question with respect to x as it is asked. Now, differentiating with respect to x, we know that 2x with respect to x is 2. Why? Because x has power 1. Power 1, if there is nothing given, then x has power 1. Then the power 1 is reduced one step back. If you know the formula, you will get to know what I am telling. Power 1 is reduced one step back, that is x power 0, that's nothing but 1. Okay, next 3 is written as it is. Why? Because it's a constant. And y power 1 is given. Y is not taken as x. Why? Because y is a different variable. Y is not a x. So dy by dx, we are differentiating y with respect to x, is the meaning of this, is equal to sin x. Here the variable is x, so there is no need of any dy by dx here. So differentiating sin x will give you cos x. Now we are supposed to find dy by dx, so dy by dx is retained in the LHS and move all the remaining terms to the RHS. On doing this, we will get cos x minus 2 over 3 divided by 3. You know how to move this, and the main thing is you should retain dy by dx on the left. The only term should be on the LHS. Now moving forward, the same problem is given with a twist. What the twist is, 2x retained, 3y is given and sin x is given, but the variable is changed. Here the function is same, but the variable here it is x and here it is y. Now differentiating with respect to x, 2x, x power 1 will reduce to x power 0, that is 1, nothing. So 2 into 1 is 2, plus 3 is retained. Why? Because it's a constant. Dy by dx here. Why? Because y on differentiating with respect to x will give you dy by dx. Now differentiating sin y with respect to x will give you cos y into, again there is a y completely retained here. Sin y differentiation is cos y, but y is retained. You should not write y as it is. You should still further differentiate it into dy by dx. The further differentiation is multiplied to the given or already written term. This rule is nothing but a chain rule. Chain rule is nothing but you should not leave y as it is. You should further differentiate such that you will get dy by dx in the term. Now combining like terms, dy by dx, take 3 this side, the like terms are combined, 2 is on LHS. Now as I told, dy by dx is retained on LHS, that will give you 2 over cos y minus 3. Simple. The chain rule is nothing but you should not leave y as it is. Now moving further to the next problem, ax plus by square is equal to cos y. This is also a simple problem. The same thing, a is written as it is and x power 1 will give us x power 0 plus b, and y square is given. Whatever be the power that will come in front of the given term into that term to the power of the already present term minus 1. That's 2 minus 1 is 1 I written here. 2 into y power 1. This is y power 1. You should not confuse with a y dash. Y dash is also a dy by dx, but for your understanding I written this as a y power 1 into, as I told you, y power 1 is nothing but a y. You should further differentiate y. That will give you dy by dx. This is the simplest differentiation. That is the simplest form in a chain rule. Till you arrive at this term, you should differentiate. You should not leave y as it is. That is the chain rule. Now is equal to differentiation of cos y is minus sin y. As I told you, y should be further differentiated to dy by dx. Why? Because you are differentiating the term with x. This is chain rule, as I told. Now combining like term dy by dx is taken on RHS and combined minus sign is retained. Now 2y is taken to the other side, 2yb is taken to the other side. Now you can see here minus sin y minus 2yb. Now this the same thing is transformed on LHS, that gives us dy by dx is equal to minus a divided by 2by plus sin y. See here minus is taken common, then this terms on getting to other side will give that minus 2a, so minus a divided by 2by plus sin y. This is so simple. Now coming back to this problem, here xy plus y square is equal to tan x plus y. Now for first term, now for your understanding there is a concept of product rule here, so for your understanding I have divided the things into a term wise. Now xy is the first term. You know product rule. Rule is nothing but the first term into differentiation of second term plus second term into differentiation of first term. You should remember in the sentence, then only you can solve. You should not remember, in the sense it's better if you remember in the sentence. Even if you are comfortable with UV rule, then it's fine. What I am telling is xy is nothing but a differentiation of first term. Whatever you can take y or you can take x, that's your wish. Take x as your first term and differentiate the second term, plus differentiation of y is dy by dx. Then take y as, that's the second term, as your first term here, and differentiation of the first term. Differentiation of the first term gives you x with respect to x is 1. Let me tell you again, first term into differentiation of second term plus second term. Here this second term will be the first term here, plus differentiation of first term. That's it. This is the first equation 1. This is the differentiation of first term of the given question. Now y square, differentiation of y square is nothing but 2. This 2 gets here, that is 2 to the power of 2 minus 1 is 1, here 1. 2 y power 1 into y, we should not leave y as it is, as I told, that is a chain rule. That's further divided into differentiated into dy by dx. Now if you know the formula, that's easy. Tan x is nothing but a secant square x. Differentiation of tan x is secant square x. And at last we have y, that is dy by dx. Now substitute this as given in the question. Substituting the differentiation of xy is nothing but we have obtained here. Substitute this here. Y square is 2y into d. Here you should multiply 2y with dy by dx. Now let me write as y dash only is equal to secant square. Substituting the same thing, secant square plus dy by dx. Now as you know, like terms are taken one side, dy by dx gives us x plus 2y, and here 1 coming to the other side gives minus 1 is equal to secant square x. This y taken to other side will give you minus y. Now taking this term to other side and divide it. That's it. This is your answer. So simple. You should remember why and what's the purpose of chain rule. You should remember why and what's the purpose of the product rule. Now coming back to this problem, the important concept here is that the differentiation of a constant is 0. You should be able to differentiate. You should be able to know that x is a variable, y is a variable, or if z is given, that is a variable. And you may notice that the letters a, b, c given in your problems are not variables, they are constant. If that's given, you should treat that as a constant, and if that's differentiated, that will give you 0. Now 100 is a constant, remember. X square is 2x plus, this is the product rule, same as given here, here the first term here, same as given here. This is the product rule. First term differentiation of second term plus second term into differentiation of first term plus y square is nothing but 2y into dy by dx. We have dealt here also is equal to 0 0 0. I have written that's if you know the concept that the constant on differentiating will give you 0. You should not take this as 100 here also. Now combining the like terms, nothing much. 2y plus x into dy by dx is equal to minus of 2x plus y. That's it. Now dy by dx retaining on the LHS will give you minus of this term divided by this term. That's it. Now moving to the last problem of today's video, x cube plus x square plus x square into y plus x y square plus y cube is equal to 81. Always remember 81 also a constant. You should be able to recognize that. Now x cube, nothing, 3x square. Reduce the power minus by one term and substitute the prefix as the previous power, 3 into x square. That's a differentiation first rule, x power n, dy by dx of x power n. Now x square into y on differentiating will give you first term x square is retained. Now differentiation of y is dy by dx plus, keeping this as same, keeping first term as same and differentiating this will give you 2 into x. That's it. That's the product rule. First term into differentiation of second term plus second term into differentiation of first term. Okay. Plus here the same thing is done. First term into differentiation of second term. The only differentiation, the only difference is here only y is given, so dy by dx. Here y square is given as a second term, so y square will first on differentiating will give you 2y. On second, from the chain rail, if you still further differentiate, will give you dy by dx. You should do that. You should not miss that. Yeah, that's the thing where students and even me fail sometimes. Okay, now 2y into dy by dx plus y square is written same thing and differentiation of x is 1 plus here y cube is given, 3y square is our differentiation, and since we have y here, that's further differentiated as dy by dx, that is chain rule is equal to 0. If you would know till this, then concept is easy. Only thing left is combine the like terms on respective sides. Here dy by dx terms are given here and taken dy by dx as common and is equal to minus of 3x square plus 2xy plus y square. Now dy by dx is this term over this term. Okay, this is the some simple problems or initial problems given in your textbook. Now what I would like to say is, always keep the formulas in your mind. You should not behead that. The way of practice what you do should retain the formulas in your brain. So what I tell is, what you must do is practice more number of problems, such that if we ask any problems, any formulas of the particular problem, you are supposed to tell that in a one shot. You should not confuse in between, or you should not do blah 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 and anything. You should remember all those things. Now we have taken our time to teach you. If you appreciate us, please subscribe our channel. Please do share to your friends, so that we will be also happy to teach you. Now thanks for the day. Thanks for watching. Thank you.